Hi, this is your host Apil Bhartia and welcome to TFiR Let's Talk. And today we have with us Ruben Stranders, co-founder and CTO of FireServiceRota. Ruben, it's great to have you on the show.
Thank you very much for having me, Swapnil.
I would love to know a bit more about what is FireServiceRota all about, since you're also a co-founder. So tell us the story behind the company.
That's a very interesting and quite long question. So I'm going to summarize it a little bit. So FireServiceRota is a company that specializes in software for emergency services, mainly firefighters in Europe. And our focus is in scheduling on one side, so planning resources, and the other side is alerting. So we alert as soon as there is an incident, make sure that all resources are mobilized and do some additional checks. We founded the company, the company was founded in 2006 by a good friend of mine, core classmates. We met in high school, and a firefighter. And a number of years later, in 2013, I joined after completing my PhD, wanting to go into industry, becoming an entrepreneur. And since then, we basically broke clean with the old version, which was written in PHP, built everything from scratch. And yeah, now we are in multiple countries in Europe, serving over 1,000 fire stations.
We all appreciate the work that fire service departments are doing. We thank them for their service, but we don't know much about this technology aspect that helps them, to go and help folks who are in need. So can you help us understand a bit, how does this whole back-end process of fire services look like? Though I fully understand that you folks are Europe-based, so different countries, it might be a bit different, but that will give us an idea of what it looks like.
So there are several parts in the process of calling out a fire station. And indeed, it starts with a 911 call, or in Europe, a 112 call. That is then routed to a command and control center. A fire operator answers the call and decides whether what the nature of the incident is, how many appliances to alert, etc., etc. That is something that we do not do, but we are integrated with those systems, which then do an API call on our systems, tell us the nature and the scale of the incident, and then we start the alerting process of, or the mobilization process of actual firefighters. Firefighters, mainly in Europe, work on a retained or voluntary basis. About 80% of all firefighters in the Netherlands, and about 30% in the UK, and I think in the US even larger percentages are retained or voluntary, which means that they have normal jobs like you and me, but carry an alerting device, could be smartphone in our case, or a pager, and that sounds as soon as there is an alert. At that point, they drop everything that they're doing, go to the fire station. Legally, they have to be there within about 5 minutes, and there they depart to the scene of the incident. So before that happens, especially in case of retained firefighters, there's a lot of coordination and scheduling going on. A voluntary firefighter, by nature, can make themselves available and unavailable throughout the day, depending on their work and family commitments. And because of that, there is quite a complex coordination, or an organic coordination problem, whereby they need to make sure as a team that they have sufficient people, sufficiently skilled people, for example, a commander, a driver, and a couple of firefighters, in order to respond to any type of incident and to protect their communities. So we give them the tools to understand when and where they're necessary, and also vice versa, when they are not necessary and can take some time off, spend some time with family, focus on work commitments, etc., etc. So as soon as there is an incident, we look at their availability, check if we have enough people, start alerting them via smartphone or smart pager, two-way pagers, and request they confirm their attendance. That triggers a whole business process of making sure that their ETA is tracked, that there are enough people responding. But also, if that's not the case, that we start escalating the alert and calling in additional resources. So we check the whole process from them being available and ensuring that there's enough resources, skilled people to the actual alert, and ensuring that sufficient people arrive to the fire station to actually respond to the incident.
Can you explain a bit in detail how does the technology work to help with the process that you just explained?
Yeah, so on the more technical level, we have several APIs to integrate with command and control systems. So they would deliver an API call with some redundancies and retries if necessary to ensure that the incident record is correctly created in our system. We use Kubernetes. We're hosted at Linode. This is for us highly scalable, auto scaling, also backups in different data centers, so we can ensure the resilience of these systems. And as soon as the API call comes in, it is routed through a so-called alerting policy. So different fire stations might have different type of alerting policy. One of the more interesting ones would be what we call demand-based mobilizing. So we look at the minimum set of users that could satisfy the requirements of an incident. For example, we need one commander, a driver, and a few firefighters. Look at who is currently available within the system. So that is a call towards the planning and scheduling subsystem, which returns the set of currently available users. And then what demand-based mobilizing does is intelligently select the people that can satisfy the minimum requirements. That can also be based on fairness. So we take into account how long it was ago that certain users were called out. And this is like a little bit of AI. We do constraint optimization there and ensuring that we call out a crew that can respond to the actual incident, but also a crew that is fair to ensure motivation. These people are volunteers. They want to protect their communities, and they want to get the opportunity to respond to incidents. So as soon as the crew has been selected, that is then passed on to a separate subsystem, which then starts alerting through voice calls. We use Twilio for this. It can be smartphones, it can be SMS, it can also be API calls or WebSocket API calls to other systems that are subscribed to these incidents. And it can also be through smart pagers. So those are dedicated alerting devices.
How much of this is automated versus manual, where people are trying to pay someone who may not be available?
It is fully automated. It requires obviously some manual data input, and that is the schedule. So we have smartphone apps where users can easily mark themselves available or unavailable. They can plan their availability in the future. They can see whether they're needed or say, no, actually, no, I'm going to book off. I'm going to make myself unavailable, go to a party, drink some beers. These are firefighters, so they need to stay under the alcohol limit. And it's very important for them to balance this flexibility with their responsibilities towards the fire service, but also their home and work life. So that is a part that is manual, but the whole part of the alerting through an API call, all the way to selecting the users who are going to be alerted, to collecting their responses, and then escalating to other users if responses don't arrive on time or people reject for various reasons, car breaking down, etc. That whole process is fully automated. It works 24/7, 365 days a year, and it's also monitored. The health is monitored by our DevOps team 24/7.
I have a very good understanding of how the whole process works. Now let's talk about the infrastructure side of it. Where does it run?
Right now it runs centralized in the cloud. So we are using the London and Frankfurt data centers of Linode. And that gives us good latency. So we're not seeing any issues in that sense. generally from the time that we receive an API call until the first responders are alerted via push notification or voice call. This is a matter of seconds, so 2, 3, 4 seconds. In terms of other technology, we use, as I mentioned before, Twilio for placing voice call and SMS. We heavily leverage Kubernetes. We use Prometheus and Grafana Opsgenie for measuring, for recording metrics, for alerting, and then also actually calling out our DevOps team should that be necessary. Usually it's more preemptive than that we actually have outages.
What is the product or service called, and what are its core components?
Our service is called the same way as our company is called. It's called FireServiceRota. So it involves all these components that I just mentioned. We have a very strong preference to the software as a service model, and all our services are indeed software as a service. So we run one version in one or multiple data centers, and that is one version that is used by all our customers across Europe. We do not use any on-premise installed software, and this has many different advantages for us. So we have one version that we need to maintain. We have one or more sets of service that we have to maintain, but it is fully under our control. And this also allows very quick and easy onboarding for our customers without them having to install or maintain and invest in IT.
First of all, the area that you work in is already very challenging. If there is a disaster, there will be a flood of calls where people are trying to get help. It's a challenge to keep the system running and scale. So can you talk about what kind of challenges are there for you folks, and what are the core technologies that you're using to make it more reliable?
I think there's two answers to that question. First is what allows us to quickly ship features to our customers. And the second is how do we keep the system running? How do we deliver the service? I think in terms of our development strategy, we are heavily agile based. So everything that can be automated, be it unit tests, performance tests, security tests, etc., is automated. We use GitOps Flux. So as soon as we make any changes to configuration, that configuration change is made in a Git repository rather than directly onto a system. So that makes it auditable, trackable, and can also be easily reverted. This is fully automated process. So as soon as something is merged into master, it goes through the process of continuous integration and continuous deployment, which is then tracked, monitored, and measured. And I think this is really important for us to be able to innovate and also take risks, right? So it's probably the opposite of what our customers want, to be exposed to risks. But all these checks, we have about 5,000 of them, allow us to take risks, knowing that if we make a mistake anywhere in the process, and given the complex product that we have, that is very likely to happen. We know that one of those 5,000 checks will warn us against, hey, you're making a change that could negatively affect this piece of functionality. And these are very detailed, since our customers can have various different ways of working. So that allows us to really innovate, work fast, knowing that we have a safety net. In terms of delivering the service to our customers, yes, so as I mentioned before, we use and leverage Kubernetes. This allows us to very quickly scale, have our infrastructure as code, quickly boot up new Kubernetes clusters if needed, for staging, for production, for very dedicated specific customers if needed, for example, for our alerting infrastructure, and then also monitor it accurately 24/7 with detailed application-specific metrics that our team needs in order to bring this service to our firefighting customers who rely on us 24/7.
Fire services have been around for a long time. What kind of evolution have you seen of these services? And when I mean services, I mean the backend process to help these departments. And what kind of evolution you continue to see to help these services serve their communities even more effectively?
That's a very interesting question. I think there's a lot of things going on within firefighting. And so I'm not a firefighter. We have several firefighters on the team who perhaps would be better suited to answer this question in terms of the actual equipment they take to the front line. But we have heard of different companies who are starting to work with drones that are automatically dispatched or mounted on top of fire trucks and then are launched as soon as they get close to the scene of the incident to provide situational awareness. We see more and more the use of, for example, Raspberry Pis to open and close doors, gates automatically as soon as an alert comes in, to make sure that the fire station is as ready as it possibly can be for the firefighters to arrive and to quickly depart. And we ourselves have also gone through an evolution and sometimes even a couple of revolutionary steps in our technology. We started off with PHP, MySQL, which was run on a server that was owned by us and co-located in a data center, to now having basically throwaway Kubernetes clusters as soon as we need them, being able to scale them up and down on demand, and making sure that we have the capacity to serve our customers also in moments of higher traffic, for example, New Year's Eve with fireworks, etc., etc.
I'm curious that while you are helping the fire departments, but are there other areas or use cases where your technologies can be used, or there are other areas that you're looking at, or this is the only focus you have at the moment?
We have been looking into other branches or other areas of service, specifically still within emergency services. But what we find is that our exclusive focus on firefighting is also a strong benefit. We are focusing on a niche, which means that we're not only a technology company, but have also gathered deep understanding and knowledge about different ways to schedule, different ways to use resources, different ways of alerting. And our team, and I would like to specifically mention our customer success team, has now very deep knowledge to support and to consult our customers in finding better ways of getting their services to their communities and protecting their services better. I think one of the nicer examples of that is we had a customer who switched from a fairly rigid duty system where users would be available during the night, during the day, and then have a couple of days off. It's called a 2-2-4 system, to something a lot more flexible, where they could have the option of self-schedule their duties based on demand. And this allowed them to free up a lot of administrative resources and move them to the front line. So we have many of these stories where our expertise, not only on the technological level, but also in scheduling, planning, and alerting, really helped our customers to create a better and safer world for their communities.
Ruben, thank you so much for taking time out today and share with us this side of the story of our heroes. And I would love to have you back on the show. Thank you.
Thank you very much for your insightful questions, Swapnil. And I always love to talk about what we do. We are very passionate about serving those who serve others.